This meeting.
So from the yesterday class, we tried to do the hot standby routing protocol lab. Let's see what we tried to do and what it did not work. So we took layer 3 switch.
No.
We took layer 3 switch 2.
Can
you please mute? These two will be connected to layer 2 switch. The layer 2 switch will be connected to the PC. So we put these two together in a HSRP group. The group IP will be 10.0.0.1. The layer 3 switch IP will be 10.0.0.2. And this one will be .3, 10.0.0.3. We define the priority as 150 here and the priority as 100 here. So we try to shut down this switch. Then the HSRP should be failed over to this one as the primary. And then we try to change the priority here to 90 less than 100. And the priority should, this one should be standby and this one should be active then. So these are the two things that we try to test. We have seen failing over when the switch go down or the interface go down, but it did not work when the priority is trying to shift. That's where we stopped yesterday. Any questions, guys, from what we tried to do yesterday and where we got struck?
No, Ravi.
Okay.
No, sir.
I'm going to do the lab again, just to make sure we complete that before we move to the next topic. So let me open the packet tracer. IP address of this one is 10.0.0.10. Subnet is 10. Subnet is 255.255.255.0. Gateway is the virtual IP, which is 10.0.0.1. And then this is the group. Virtual IP is 10.0.0.1. And then we have physical IP 10.0.0.2. The physical IP is 10.0.0.3. Priority 150. Priority is 100. And then this is HSRP group 1. You can take any number. I pick the number, group number as 1. And then, yeah, let's put this one in VLAN 10. And this one should be trunk hello VLAN 10. This also trunk hello VLAN 10. Okay. All right. So now let's save this one. Okay. I'm gonna go here on the PC. I'm gonna define the IP address 10.0.0.10 and define the subnet mask 5.2.5.2.5.0. Let's go to the settings and then define the gateway 10.0.0.1. The gateway is nothing but the group IP that we define on this interface. And then next, this configuration is done on the PC. Now I'm going to the switch. On the switch, I'm defining the VLAN number and assigning this port as the access port. Access port. And then I'm putting this port, this specific port. FA0/1. Assign VLAN 10 to FA0/1. Okay. Okay, I'm gonna go to the switch. Okay, I'm gonna do enable config mode VLAN space 10. We'll define the name Jan10 HSRP VLAN. Okay. And then I will have to assign the VLAN 10 to the specific port, interface FA0/1, switch port mode access, switch port access VLAN 10. So I assign this port to the VLAN 10 now. I can check that by using the command show VLAN ID 10. Okay, I created a VLAN number 10 with this name and it's assigned to the port FA0/1. So this part is done. Now we have to allow the VLAN 10 on 0/2 and 0/3. So allow VLAN 10 on trunk ports FA0/2 and FA0/3. FA0/2 and FA0/3. Okay. Conf terminal again, interface range. If I use the range command, I can do I can pick multiple interfaces and I can put the same configuration on both the ports. So I can do FA0/2-3. Okay, I can do the same configuration. Instead of doing 2 times, I can apply changes on the multiple interfaces. I can do switch port mode trunk, switch port trunk allowed VLAN 10. Okay, I can do that. So this part is done. We did access port and then we did trunk port and allowed the VLAN 10 on both the trunk ports. Now here we have to assign the VLAN 5 here and create those trunk ports and allow those ports on these interfaces and also create the layer 3 interface for the 10.0.2 and 10.0.0.3. So let's do that. Enable. Let's define the name of the switch. Let's put this name HSRP primary Let's this as HSRP secondary. So I'm going to go here and then define the host name. HSRP primary. Okay, now let's go here and then define the HSRP secondary. Enable on T host name HSRP secondary. Let's save the configs. Okay, so now let's go here and then create the layer 3 interface, and we define the IP address of the layer 3 interface on this one. So I'm going to go here, interface. Before we create the layer 3 interface, let's create the layer 2. Okay, VLAN 5 name HSR Jan10 HSRP VLAN. Here also config terminal VLAN 10 Jan10. Let's see, did I create a VLAN 5 or VLAN 10? No, I created a VLAN 5, so that is not correct. I have to remove that. So to remove that, I have to do no VLAN 5. I have to do VLAN 10 name Jan10 just like VLAN. I can do show VLAN ID 10. Okay, this is there, and also I have to do show VLAN ID 10. Okay, this is there. So now this port should be the trunk port, and this port should be the trunk port. So now trunk VLAN 10 on FA0/1. Yes, so interface FA0/1 switch port mode, switch port trunk encapsulation .1Q, switch port mode trunk, switch port trunk allowed VLAN 10. Okay, similarly here, config terminal interface VLAN 10. Interface FA0/1 switch port trunk encapsulation .1Q, switch port mode trunk, switch port trunk allowed VLAN 10. Can do show interface trunk, which is FA0/1 is trunk, and then 10 is allowed. You can also do here show interface trunk. Okay, all right. So now layer 2, layer 3, configuration is done. Now let's go to layer 3 and assign the IP addresses to this switch and this switch. Okay, so I'm going to go to this one, do interface VLAN 10 IP address 10.0.0.2 255.255.255.0. Okay, here also config terminal interface VLAN IP address as 10.0.0.3 255.255.255.0. No sure. You can do show space IP space interfaces brief. So VLAN 10 is defined with the IP address. It says up and up. So that means layer 2 and layer 1 is up. Here also we can do show IP interface brief. Okay, 10.0 is up and up. Now we have done the physical interface configurations, right? So now we have to define the virtual IP on this one and virtual IP on this one for the HSRP group. Okay, so now we have to configure the actual HSRP IP. So config terminal interface VLAN 10 standby, and the group number is 1. You can do IP 10.0.0.1. That is the interface IP. I mean the virtual IP. Here also interface VLAN 10 standby 1 IP 10.0.0.1. Okay, and now we have to define the priorities. So here we have to define the priority standby 1 priority as 150. Here standby 1 priority as 100. Okay. Now we discussed about the preempt yesterday, right? So we have to put the preempt, standby 1 preempt, and standby 1 preempt. What is the concept of preempt, guys? Preempt means if the primary is up and accepting the traffic, if the primary goes down or if there is any change in the primary, the traffic should be failed over to the secondary. That is the meaning of preempt. Any questions, guys?
No, sir.
Okay, so now let's see, show standby. It says VLAN 10 state is standby, the priority is 100. Okay, let's go here and then check show standby. So now we are on the primary switch, HSRP primary switch. If you see the primary, it says the state is active. So the primary switch, which is on the left hand side, this one got the priority as 150. So got the priority as 150 and the state is active on this device. So here if you see the secondary, the HSRP secondary switch got the priority as 100 and the state is standby here. So now what we have to test is if this link go down, okay, if FA0/1 go down, the primary, technically the switch has no reachability for this PC. So now let's see, before we shut down this PC, let's see how the traffic flow occurs. Okay, so let's do the right map to save the configuration. Here also let's do the right map. Here also do the right map. Right map means that we are saving the configuration so that if for some reason if the lab got crashed, like the packet tracer got closed, then it should be able to save the configuration and it will not get loose. We don't have to reconfigure again, just like yesterday. That's why I'm making sure I'm saving the configuration in the middle of the labs. Okay, so now let's try to delete some ARP and then try to generate some traffic. Now, as per one second, stop share and then share the whiteboard. Okay, so now as per the priorities, this one, the traffic should come to the switch 1 because this one got it should broadcast to this one and it should broadcast to this one. But because this got the high priority, this one should reply back and then that should come back to the PC1. From the next packet, it should automatically go to the active device because this one replied the first packet. All right, so that should be the theory. So now let's see how it behaves. So I'm going to go to PC0. Before I start this one, let me delete the ARP. I'm going to go to simulation, start the simulation, go here, ping 10.0.0.1. PC0 send the broadcast to the switch 0. Look at the green color packet. Now this packet should be broadcasted to both the layer 3 switches. This one did not reply. It's the cross marking out. This is replying back for the switch. and this is replying back to the PC0. So it got the reply back. So from the next packet, it should be unicast packet. It should not be broadcasted. It should not be sent to the both the switches. It should be sending to only to the primary. It's sending only to the primary. This one is replying back. Got the response to the PC0. So from this, we identified that, okay, the packet went all the way to the primary. Okay, now let's bring this interface down. Let's go to real time. So what I'm going to do is, I'm going to bring this interface down. So I'm going to make this interface down and then see how the HSRP will be changed. Okay, I'm going to do interface FA0/1 shut. Okay, so now this interface went down. Earlier, this was HSRP secondary, right? If you observe, this is state is standby. So now let's see. Now it says state changed from standby to active. So now let's check the. It says state is active. Okay. And if you see show standby brief, it says the state is active for the local device, but the standby is unknown because this device went down. So it says this device is unknown. So now let's bring up this interface, guys. So now tell me, when this switch comes up, will this take over the role of the primary, or will this one stays as the primary?
Should go as primary.
Yeah, this one should go back primary because the preempt will kick in. It will make sure that the higher priority came back online. So that should kick in and then it should become the primary. Okay. So I'll do no shutdown. Okay, so it's up now. So if you see now, let's wait the HSRP. Let's wait for the link to be up. Green. It says speak to standby and standby to active. So now if you observe, this one should be the standby. So earlier it was active. Still it was active. Now let's see. It's in the speak state now. Speaking again. Speaking still. Now it's standby. So it was active earlier. It was in the speak state, speak, and went to the standby. Let's look at this one. So earlier, after we shut down, it was in the standby earlier. Now it has to be active. Yeah, state is active now. Okay. So now what I'm going to do is, instead of shutting down the link, this one priority is 100. I'm going to make this priority as 160. So this should take over the role of the primary now. Okay. Interface VLAN 10, standby 1, priority 160. See, it became standby to active. Let's look at this one. Earlier it was active. Now if I do show standby, this one should be the standby. Okay. It is still in speaking state. Still in speaking state. Still in speak state. Yep. Now it went to standby. It is in standby now. Okay. So now this one should be active. Earlier it was standby. Now it should be active. Now it is active and the priority became 160. Okay. So when we adjusted the primary, so now when I generate the traffic from here, this one should be broadcasted and now this one should be replying back, not this one. Okay. So I'm going to send the back. I'm going to start the simulation again. Start it. And then go here. This one, sending the packet to the switch. This one sent to this one. Broadcasting again, I believe, because the first one failed. It's going to the this switch. The switch will update its MAC address table. We should have done the ARP clearing, guys. Before we should have done that because the ARPs are not getting updated. So let me clear the ARP before we do that. 1 second. I'm gonna clear the ARP here. Shut up. You started replying, but we should have cleared the ARP. And now let's do the simulation. Start. Go here. Okay. Now I'm gonna send the broadcast packet. It should go to both of them, the broadcast packet to the PC. It's going to both. This one did not respond. This one responded. Now the reply is coming back to this guy. This one did not respond again for the broadcast. This one is responding. This one should come back to the PC0. Yep. Okay. Now the next packet should be going to the switch. Switch should automatically send to only to the HSRP secondary device because it is primary now. Yep, it's going to HSRP secondary only. It's not going to primary. It's coming back. I'm going to the PC and it got successful from that one. Okay, that completes our theory part, and the lab proved that it will fail over when the switch go down, or if we change the priorities, there should be a failover between the switches. Any questions, guys?
No, sir.
Is it clear? Is it better from yesterday?
Yes, sir.
Yes, sir.
Okay, all right. Let's move on to the next topic. We literally wasted all of the class yesterday, but it is what it is. We have to continue. Let me stop share. And then we'll do the whiteboard again. 1 second. Okay, guys, we have to talk about Inter-VLAN routing now. So let's continue what we have to check on Inter-VLAN routing. So give me 1 second. Let me bring back the whiteboard. I'm not sure why if the Zoom got updated or something, I cannot change the colors on the whiteboard. Let me try share. Okay, all right, it's back now. Okay, so we have seen a lab. So we have taken a switch. We have taken a switch 1, and then switch 2. We have taken We have taken this one. What we have done was we have put this is PC1. We put it in VLAN 10. Oh, these colors. Okay, that's fine. This is in VLAN 10, and we put in PC2 in VLAN 20, PC4 in VLAN 20, and then we did PC3 PC3 in VLAN 10. Do you guys remember this lab that we have done?
Yes, sir.
So we did a trunk port between these guys, and we did trunk hello VLAN 10, 20. Okay. So what we have done was we did tried communicating from PC1 to PC3 and then PC2 to PC4. While we are discussing when we are discussing this lab, we talked about the inter-VLAN communication is only possible via router. Do you guys remember that? So now if PC1 wants to talk to PC2 or PC1 wants to talk to PC4, it has to pass through a router. So technically, what we will do is we will do a routing on a stick lab now. We will see how we can make two VLANs communicate with the help of a router. So on the concept of HSRP, in the similar design, how we will accomplish that is, so let's do this. So I'm going to remove the switch 2 and this trunk port. And what I'll do is I'll pick a router. Okay. So here from switch to router, I'll create a trunk port. Okay. So I'll allow trunk allow VLAN 10, VLAN 20. Okay. So on the router, I will create two interfaces. One for VLAN 10, second one for VLAN 20. We all know that a router can perform communication between two VLANs, but a switch cannot do that. You know, a switch can only do the broadcast. It can send the frames only in that VLAN. It can separate them into multiple VLANs, but it cannot communicate between inter-VLANs, but a router can do that. So we will allow both VLAN 10 and VLAN 20 to the router, and we can make the router to send the packets between the VLANs by the IP address communication. So we will create two interfaces, one for the VLAN 10 and one for the VLAN 20, and we assign the IP addresses. We will define the PC1 gateway as the router 1 IP, and we will define the PC2 IP as router 1 VLAN 20 IP, and then we will let the router communicate, make them communicate between them. For that, we have to trunk the VLAN to the router and let the router do the communication between these two interfaces by looking at the routing table. Okay. Any questions on the theory part, guys?
No, sir.
Anyone? Is this clear, guys?
So we should keep the trunk
So a
port
router
between
will be able to communicate two VLANs or two subnetworks. If you consider VLAN, it's a layer 2 terminology. If you say subnetwork, it's a layer 3 terminology. But technically both are same. So a router can be able to communicate between two VLANs or two subnetworks. So what I'm doing is I'm creating a subnetwork 1. I'm putting PC1 into that. I'm creating a subnetwork 2. I'm putting PC2 in that VLAN or in that subnetwork. I'm letting them pass to the router, and I'll let the router to make them communicate between them with a routing table, and then make sure that PC1 will be able to talk to PC2 with the help of the router. We will simulate that now in the lab. Someone is asking a question. Can you tell me now? Okay. If no questions, let's move on to the lab again. Let's do a router on a stick lab now. Let's continue it. All right. So okay, PC1 is there. Let's connect both of them to switch. I'll take a switch. RPC without a switch. Okay. So as per the idea, this one, VLAN 10, VLAN 10, this is VLAN 20. Hello, VLAN 20. Hello, VLAN 10. So I'm going to take this IP as 10.0.0.10. I'm going to take this IP as 20.0.0.10 for VLAN 20. I'm defining the gateway as 10.0.0.1. I'm going to define the gateway as 20.0.0.1. Okay. So now I'm going to define the gateways here. Gateway for VLAN 10, 10.0.0.1, 0.0.1, gateway for VLAN 20.0.0.1. Okay. So now for the intercommunication to happen, the PC0 should be going to the switch 0. Switch 0 should be trunking that to the router. On the router, we'll create the gateway. It has to go to the gateway, and the gateway should route to the gateway 20, and it should come back and talk to the PC1. So the inter-VLAN communication should be accomplished by the router in this case, with the gateways configured on the router. Okay. Simple concept, guys. A PC is trying to go outside of its network. So if it's want to go outside of its network, it has to go its gateway. So think about okay. So let's go back to the whiteboard. So you have a PC1 and you have a PC2. This is in one network and this is in a different network. And if it wants to go outside of its network, it has to talk to a gateway. And if this wants to talk to the outside network, it has to talk to the gateway. And this gateway is nothing but the router. So the router is where you will define your gateways, and this router will help to communicate between this PC to the other PC between the subnets. Okay, so that's what we are trying to accomplish. Okay, any questions, guys?
No.
Okay, all right.
I have a question.
Okay, go ahead, please.
So can two routers communicate with each other? If we have another two PCs which are connected to another router, and is there any possibility that two routers can communicate with each other?
Yes, I mean, so your question is simple if they are part of the same network. So the other router PCs, are they part of the same network?
No, if they are part of another network.
Okay, then we need to have a routing protocol to make them communicate between them.
Okay.
So your question is, let's go back to the whiteboard. Let me delete all of this. So your question is, there is a router which is
Yes.
called router 1. There is another router which is called router 2.
Yes.
We have some networks here.
Yeah.
We have some networks here.
Yes.
And these two can be communicated using this router. These two can be communicating this router. Now, if this one wants to communicate with this one, can this router make communication with this router? Is that your
Yes.
question?
Yes.
Yes, this can be done.
Okay.
Absolutely. This can be done with a routing protocol. We can do like static routing, or we can do dynamic routing. There are multiple ways you can accomplish this.
Okay. Okay. Thank you. And I have one more question which I want to ask. So, so IP address we give to the PCs or any device, are they static or dynamic? They are dynamic, right?
They can be both. You can statically configure an IP address that which cannot change. You can also use a DHCP server which will dynamically allocate the IP addresses. So the answer is both.
Okay. Thank you.
Anything else?
No, thank you.
Okay. All right. Let's go to the lab. Let's go back to the lab. Okay. Going back. So PC0. Let's define the IP address 10.0.0.10. Let's define the gateway. Okay. PC1. (20.0.0.10). And then define the gateway. Okay, this part is done. So now let's go to switch 0. Assign this port in VLAN 10. Assign this port in VLAN 20. So 0/1 is in VLAN 10, 0/20 is in VLAN 20. Let's give these VLANs names. I'm going to give this VLAN name as lab 1. Now this as lab 2. Okay. On free VLAN 10, name as lab 1. Exit VLAN 20, name as lab 2. Exit. I have to assign the FA0/1 in VLAN 10. So interface FA0/1, switch port mode access, switch port access VLAN 10. I have to assign VLAN FA0/2 in VLAN 20. So interface FA0/2, switch port mode access, switch port access VLAN 20. So we are done with this part and this part. Now we have to create this trunk port and allow both VLAN 10 and 20. FA0/3. Interface FA0/3, switch port mode trunk, switch port trunk allowed VLAN 10, 20. Okay, we'll save it, write name, we'll save here. Now let's go to the router and then create this as the sub interface of gateway VLAN 10 and VLAN 20 and assign the IP addresses to this one. Okay, so let's see what interface it is. Interface gig 0/0/0. Enable conf t interface gig 0/0/0 node shut. Okay, and then we have to create sub interfaces for VLAN 10 and VLAN 20. So sub interface is nothing but the where we can define the IP addresses. For this interface, I'm going to create two interfaces, sub interfaces, where I can assign two IP addresses, right? Because I have two VLANs, I have to assign two IP addresses. So what I'm going to do is I'll define gig 0/0/0.10, for which I'm going to define 10.0.0.1. Similarly, I'll define gig 0/0/0.20. For that, I will define 20.0.0.1. Okay. And I have to allow those VLANs over the trunk, right? So I have to define the encapsulation as well on that interface. So what I'm going to do is, so interface gig, let's go back. Interface gig 0/0/0.10. I will do encapsulation .1q and define the tag. For .10, I'm going to define the tag as 10. And then I can define the IP address here. IP address as 10.0.0.1, 255.255.255.0. Okay. I can check that by using the command show IP space interface space brief. It says gig 0/0/0.10, you assigned IP address as 10.0.0.1, status is up and the protocol is up. Okay. Similarly, I'm going to define the .20 now, config terminal interface gig 0/0/0.20 encapsulation .1q 20 tag, and then IP address 20.0.0.1, 255.255.255.0. Okay, to check that, show space IP space interface space brief. Okay. Now let's see if the PC 10.0.0.10 is able to ping the 10.0.0.1. Similarly, 20.0.0.10 is able to ping the 20.0.0.1. Let's see if these PCs are able to connect to the gateways first. I'm going to go to here, desktop, command prompt, ping 10.0.0.1. I was able to ping my gateway. Now let's go here, then ping the my gateway, which is 20 network gateway on the PC1. Ping 20.0.0.1. Able to ping it. So this PC is able to ping its gateway. This PC is able to ping its gateway. Now let's see if the PC is able to ping the PC1 or not. Okay. So let's do the simulation. Let's to validate how the packet is going. I'll just put this one here. Simulation start. Go here and then ping 20.0.0.10. So now the packet went to the switch. Switch will only broadcast to that VLAN, so it should only go to that router gateway. So the gateway got it. The gateway should check its routing table. It should go back to that specific tag. It should come back to the switch. It should only send to this VLAN tag. It's getting it. This one should reply back that it is the destination that it's trying to look for. It replied back. The switch got it. Now switch should send that to the router. The router will save it in the ARP table. it will send back to the switch because now the response is in that VLAN source VLAN tag. It got it and it should send back to the PC0. So now the PC0 got the reply back. So if you go to the real time and if you check it, it's able to ping. So here from here, it's going all the way to the gateway. It's going to this PC and coming back and then going here. So that is how the inter-VLAN communication works. So you can check the ARP entries of this one. If you do ARP-A, it is showing its gateway ARP entry in its ARP table. If you look at the ARP table here, it will show both the PCs ARPs here. If you do show IPR, you will see 10.0.0.10 with its MAC address, 20.0.0.10 with its MAC address, which are nothing but the host 1, PC0 and the PC1. Both the ARPs are learned here. And you can also check the routing table. You will see that this route is learned from this interface and this route is learned from this interface. For that, you need to enter the command show IP route. So if you see 10.0.0/24 is connected via .10 network, 20.0.0/24 is learned via .20 network. That's how it was able to route the packets between the sub interfaces. So this is the fundamental routing concept that you should be familiar with. So I request kindly everyone to create your own router on a stick lab, understand the mechanism, and if you have any questions, feel free to reach out to me in tomorrow's class. Okay, any questions on this lab, guys? Are you guys able to follow?
Yes.
Yes,
Yes, sir.
Yes, sir.
Okay, all right.
Sir, can you upload like previous videos, session videos, last Monday and Tuesday?
Yeah, I will do it, but yesterday class is like, it's just pure troubleshooting. So I don't want to put that and make more confusion. So let's leave yesterday class.
Okay.
Today's class and Monday's class is good enough. What do you guys
Okay.
think?
Okay, sir.
Okay, sir.
Yeah. Okay. Any other questions?
Sir, about the exam, I have a few doubts. Like,
Let me stop the recording then.
yeah,
Any questions regarding the class?
no, I'm good.
Yes, Ninesha? Okay. All right. I think there is no question. I'll stop the recording.